A first grade teacher shops online for bottles of hand sanitizer for her first grade classroom. She finds large bottles for $5 each on a website. Write a function representing the cost, C of X, for X bottles of hand sanitizer. So with any application problem or real-world problem, it's always a good idea to keep track of your variables. Sometimes a problem will tell you what the variables represent, and sometimes you get to choose what the variables represent. In this case, this problem is very specific. It says that X is the number of bottles of hand sanitizer. So even though that's written there in the problem in part A, I think it's a good idea to actually write it down. I call it a variable key. I recommend that you do that each time you have any sort of a word problem or story problem. We're trying to write a function representing the cost, which is C, for X bottles of hand sanitizer. So C is going to be our cost or our output. We're going to assume that the cost is in dollars in this case, since we had a measurement of dollars here, $5. We're not measuring in pesos or euros or something else. So a function tells us two things. We want an equation where I put in the number of bottles that we want to buy and the output will be the cost. And it also tells me that I want to use function notation. And by function notation, I mean I want to write C of X instead of writing just C is equal. And one great strategy, if you struggle with writing your own equations to match real-world situations, a great strategy is to make a table. This is a good way to stay organized, to grab the information from the problem, begin to process it in a mathematical way. So a quick table here, X is the number of bottles of hand sanitizer. So if I don't buy any bottles, then my cost is $0. If I buy only one bottle of hand sanitizer, I have a cost of $5. And then 2 bottles, of course, 5 times 2, that would be a cost of $10, 3 bottles, a cost of $15, and so on. And that may help you realize that we have this increase of $5 each time for a cost, every time our number of bottles is increasing by 1 here. So just reminding you that this is a linear relationship. We have a constant rate of change. We're going up by $5 for every 1 bottle of hand sanitizer. So that's basically like having a slope of 5. That's my rate of change, and therefore my equation for cost would just be C of X is equal to 5X. Put in the number of bottles of hand sanitizer, multiply by 5, we'll get the cost. Now part B is asking if there is a 6.5% sales tax on the cost of merchandise for this website, and there's a fixed shipping cost of $4.99, we'd like to write a function that represents the total cost, T, and that's T of D, where D is the dollars spent in merchandise. So now our function that we're writing is T for total cost, and it's T as a function of D being dollars. But now we need to take into account the fixed shipping cost and the sales tax. You can do these in any order. I like to talk about the fixed shipping cost first. I know that I'm going to be charged the $4.99 regardless of how much money I spend or how many bottles of hand sanitizer I buy. So I'm going to have $4.99 plus then the cost for the hand sanitizer. So if D is the number of dollars that I'm spending on the merchandise, I know I have to spend my D dollars. That's going to be part of my cost. Plus, I have to pay the sales tax. Now, the sales tax is 6.5%. So remember, with percentages like this, we need to convert this to a decimal, from a percent to a decimal. So 6.5%, you're going to move that decimal 2 places to the left. That's 0.065. So I would have to multiply the number of dollars that I spend by the 0.065. So this will tell us how much I'm having to pay in taxes. Then the D is how much I was actually paying in total. And then the $4.99 is my shipping. So we can simplify this a bit. My total cost as a function of dollars spent. If we go ahead and add our like terms, we have D plus 0.065D. So that would be a total of 1.065D plus the $4.99 shipping. Now part C says we want to go ahead and compute a composition, T of C of X. Notice how I read that. because I know you're learning a language here, right? The language of mathematics. So there's symbols that we have to learn, and we want to learn how to say and how to write those new symbols correctly as well. So this is T of C of X. That could also be written like this, T of C of X. And that's getting rid of that open dot, which tells us we have composition, and rewriting it in this form with the parentheses. I like this form though because this helps those of us that are visual. We can see that the C function, the cost function, is being inputted. It's inside of the T function, the total cost function. So basically what this is saying is we're going to take our cost. We know the cost was 5x, where x was the number of bottles of hand sanitizer. We're going to take that cost function and we're going to input it here. If D is dollars spent, well, then my cost was the number of dollars I was spending. We're going to input it into our T total cost function in place of D. And that means we're going to end up doing this composition. So the total cost function we wrote earlier was 1.065D. I'm going to leave a blank there, plus $4.99, to then show you that I'm inputting my cost function, which was 5x. I'm substituting the cost function into the total cost function. So that way I'm going to end up with a total cost as a function of x. So go ahead and multiply 1.065 times 5. And we're going to end up with this total cost function, which is T of C of X, is equal to 5.325x plus 4.99. So what does this function actually mean? We're going to explain the meaning. This is the total cost as a function of x, where x was a number of bottles of hand sanitizer. So I can put in the number of bottles that I want to buy, and out I'm going to get my total cost, which is going to include the shipping cost of $4.99 plus the sales tax amount. So for part D, if I'm asked to compute T of C of 5, rewritten, that would be T of C of 5, written like this. This is telling me that I'm going to be inputting x equals 5. So that means 5 bottles of hand sanitizer. And by using this lovely function that we've created, the 5.325x plus $4.99, if I go ahead and plug in 5, then that means I'm going to get out my total cost without having to figure out first how much did the bottles cost, and then add in the sales tax and the $4.99 shipping. This total cost function is a more direct function. It allows me to go straight from the number of bottles of hand sanitizer to my total cost. And that looks to be 31.615. So since this problem did say, let's interpret the meaning, I will write that out in words. We're basically saying that 5 bottles of hand sanitizer will cost approximately, and I'm going to say approximately because I'm going to round, since we're talking about dollars, I'm going to round this to the nearest cent. So it will cost approximately $31.62. 5 bottles of hand sanitizer will cost approximately $31.62, and that's going to include the sales tax as well as the shipping.